Hello everybody. In this video, I will try to explain what are the essentials when we deal with a optical wireless link with the pre-coding. We focus on a MISO, where MISO is the acronym of multiple input and single output communication. And in particular, we will consider the presence of two LEDs able to transmit signals through the emission of light and a single photodetector. And I will focus on precoding. Precoding is a countermeasure that we can adopt at the transmitter in order to avoid some bad effects, let's say impairments induced by the optical free propagation. And in this context, I am going to show you two different situations: the conventional transmission without any kind of precoding, and a proposal by our team that is related to modulation precoding. And I'll try to give some very short essentials and also show you the performance on a real link. Okay, you can see here the signal generator. The green pattern is essentially the second channel we are going to use to transmit, while the pink-orange one represents the first channel. So we have two independent channels transmitting two binary signals, and the signals are essentially identical in the sense that it is a square wave ranging from 0 volts to 5 volts. Then, as you can see, we have two LEDs with a couple of lenses in front of them, and we have an oscilloscope, and the role played by the oscilloscope will be clearer in the following, so in the next frames of the video. So if we turn on the transmission of this pattern, well, you can appreciate the LEDs blinking with a low rate because we want to show you what is happening. And this is the signal that is present at the photodetector. So as you can see, it is a square wave, and I will give you some more details about this. Here, the photodetector that is illuminated by the two lights coming from the two LEDs that you can see here, even though, let me say, that is not so in focus, out of focus, yeah. Okay, so the use of the lens is just to improve the power received. And obviously, the signal is captured by a MATLAB-based software that is showing on the screen the samples. And most interesting, you can see on the oscilloscope, essentially, that while we are transmitting without any kind of precoding, because here we have square wave ranging from 0 to 5, so two identical in the dynamic that we can tackle for the signal generator, then we are transmitting essentially the same modulation format. So it is a binary PIM from one LED and binary PAM from the other LED. So looking at this picture, but you can infer the same kind of information by looking at the oscilloscope, it is possible to understand that we have essentially three different levels. One is the low level, one is the intermediate level, and one is the highest level. So we have three levels. So the lowest one is due to the case of 0 volt and 0 volt, so the LED is in the off state, and the same is for the second one. The highest value is achieved when the two LEDs are both in the on state. So in the intermediate one is due to one LED on and one LED off. And unfortunately, we are unable here to understand who is on and who is off. Because due to the effect of the channel, due to the propagation of the optical signal in the free space, you have that at your photodetector, you are perceiving the sum of the two lights. So just in case one is turned off and the other is turned on, you are simply looking on the light emitted by, let's say, for example, the second LED. But the same is from the first LED. So since the channel that we have from the first LED to the photodetector is essentially the same of the channel from the second LED to the photodetector, we can say that there is a very strong ambiguity. So let's say that the receiver is unable, even though if we know the channel, because in this case, as you can see, essentially we have two very close signals in the sense of the Euclidean distance. That is a really important parameter when we deal with detection. So in other words, we can say that what we are receiving in this case is essentially H1 multiplied by the light emitted by the first LEDs, and in the other case H2, where H2 is the coefficient modeling the channel from LED number 2 and the photodetector. So H1 and H2 are really similar, so the optical power that we are receiving is more or less the same. So in that case we are unable to recognize the right symbol we have transmitted. So this is the reason why in this case, where no precoding is acted, essentially we have a very big distance between the off-off case, so off-off stands for off the first LED and off the second one, and the on-on case. Okay, but the Euclidean distance between on-off and off-on is very, very short. So every time that we have LEDs in different states, so one is on and one is off, that is, let's say, high probable that we are induced in error during the detection mechanism. So we have on this software at the end of the transmission procedure, and we are transmitting several bits just to measure in a reliable way the symbol error rate. So we are measuring the number of errors divided by the number of transmitted symbols. So later I proposed a different situation where we consider obviously the precoding, and we will appreciate the difference in terms of reliability of the link. So the transmission is almost ended, and we are able to see here the symbol error rate that equates more or less 0.25. In this case, we are watching now still the signal generator. In this case, we use different amplitudes for transmitting symbols, because despite of the conventional transmission independently, emitting on the first LED two different amplitudes and the same for the second LEDs, here we are trying to optimize the constellation. If you remember, before we had 3 different amplitude levels, while here we can recognize 4 different levels, because we are considering the case in which we use 2 amplitude levels, because it is a binary PAM for one LED and a binary PAM for the second LED. Differently from the previous case, here we are trying to optimize our constellation. The constellation that we are trying to optimize obviously is performed at the transmitter, because there we can allocate different power levels. But the focus is about the receiver, because at the receiver side we want to have 4 different levels. And this is not all. We want to try to optimize the symbols at the receiver. From this point of view, you can understand why we name this procedure precoding. This precoding because we need channel knowledge at the transmitter. So this is the reason why we measure the channel and we consider the effect of the channel by posing the LEDs in specific places with a specific distance from the photodetector. We measured in advance the channel gains and then we use for optimization. Obviously, in a fully functioning system where we have a transmitter, receiver, and a possibly feedback link, we should try to measure the channel and adapt the power levels. But just for now, as you can see here, we have 4 different levels and more. That is probably one of the key aspects. These amplitude values that are 4, as you can also see in this part of the video, the amplitudes are equidistant. And this is really important because you know that the performance of a system in terms of reliability, that's meaning error probability, that's meaning symbol error rate or bit error rate, essentially depends on the Euclidean distance, and above all, the minimum Euclidean distance. So when possible, because it depends on channel gains, we can try to have at the receiver, in this case, 4 different amplitudes, given by the combination of 2 possible amplitudes at the LED number 1 and 2 possible amplitudes at LED number 2. So 4 different amplitude levels that are equidistant. So since the minimum Euclidean distance matters and dominates the performance, we have a system where we have among consequent symbols the same distance. So when we consider 2 close symbols, so level 0 and level 1, or level 1 and level 2, or level 2 and level 3, well, the distance is the same. Obviously, if the channel changes, we need to rearrange the amplitude And this can be done easily at the receiver, because also the receiver needs to have information about the channel. So the receiver can compute the values and send back, or can send the channel gains. It doesn't matter. The procedure is the same. Can be computed at the receiver, or receiver and transmitter can cooperate in order to have the same information. But the key point is that in this case we are able to maximize the minimum Euclidean distance at the receiver. So this justifies the name we gave to this approach, that is modulation precoding, because usually when you have one LED transmitting and another LED transmitting, since the signals, the lights coming from the two LEDs are overlapping, we can name that effect interference, or if you prefer, crosstalk. Okay? Well, this is not the case. And more, as you can see, we are stressing, we are using this information in order to gain a lot, because we are close to 6.4 multiplied by 10 to minus 4. Summarizing, our system is able to outperform the conventional MISO transmission, and more, let's say that we are rephrasing the concept of MISO, because in MISO you have that transmissions operated by each LED generates interference. In this way we are obtaining a sort of cooperation, in the sense of we are transmitting independent streams on different LEDs, but at the same time we are mapping, we are using optimized power level in order to map the power levels at the receiver so as to present our constellation, despite of the effect of the noise, as an equidistance constellation. In that case, we are able to obtain the maximization of the minimum Euclidean distance, so as to have to the minimum symbol error rate. So let's say I didn't go so in that, but let's say in the paper that comes from this work, there is also a part where the optimization problem is also linked to the illumination level that is constrained, because we want to assure a good average illumination that is uniform among the room. So I hope that you have appreciated this video. Just in case you have comments, questions, feel free to comment here on the YouTube or something similar. You can use also my email, and I am very happy to reply, to hear from you. Thanks for your attention.